All right, so today's lesson we're going to talk about an idea called divisibility. So let's start with a couple general definitions here. In general, A is a non-negative integer. Non-negative meaning positive or zero, and B is a positive integer. We say that A is divisible by B, or B divides A if and only if the remainder is zero when A is divided by B. For any whole numbers, A and B, where B is not equal to zero, B divides A if and only if there is a unique number Q such that A equals B times Q. Okay, so what does this all mean? And this introduces a new symbol. So this B slash A means B divides A, means that B is a factor or divisor of A, and A is a multiple of B. Okay, so sort of have this new symbol that we're going to use throughout the lesson. B slash A means that B divides into A. We're not necessarily at this time worried about how many times. We know 2 divides into 6, and we also know the remainder would 3 times. But we're not stressed about that, how many times it evenly goes in. We're just talking about whether it goes into it evenly or not. Okay, so just to help us make sure we understand how to use the symbol properly and what some implications of the symbol are, I'm going to start with a couple of statements, and we're going to go back and discuss whether they're true or false. Okay, so not everything I write is going to be true, but we want to make sure we understand how this symbol works. So let me write a couple of statements. For any number, for all whole numbers, A1 divides into A. And then for all non-zero whole numbers, A squared divides into A to the 5th. Write that a little clearer. Make sure we fully understand what that means. Okay, so let me go back up and let's see if we get the idea here. 3 divides into 12. Is that a true statement? Well, when we say divides into, can we think of a number that 3 times something will give us 12? Well, because 3 times 4 is 12, that means 3 divides into 12 evenly. So therefore 3 is divisible into 12. So it's a true statement. What about 0? Is 0 divisible by 2, or 0 into 2? Okay. So we need to think, is there some number times 0 that will generate 2? And that's false. Okay. 8 not divisible into 2. Okay, so what that says, we have 8 times some number equal to 2. And we need to kind of clarify, because technically if we bring fractions into this, then sure, yeah, we're good to go, because we could say 1/4 of 8 is 2. However, back up to our definitions for a second. When we talk about multiples, we're looking at whole numbers. So in general, right up here, it says A is a non-negative integer and B is a positive integer. So we don't have fractions as an option when we're looking at this. So this is false because there is no integer that will ever make that statement true. Okay. For all whole numbers, A, 1 is divisible into A. Okay. Oops. Okay, so we're going to start looking at some properties and theorems dealing with divisibility. So starting with this one, for any whole number a and d, if d divides into a and n is a whole number, then I know d also divides into n times a. Okay, so let's kind of put some thought into this. So I need two whole numbers that are where one's divisible in the other one. Okay, so let's do 2 and 6. Okay, so take a look, 2 and 6 for example. Okay, so I'm going to say that 2 divides into 6. Now that's true because 2 times 3 equals 6. So I can think of a whole number, or I can think of an integer that I can multiply 2 by to get 6. Okay. Now we need any number n, so let's do n equals 3. So what this rule says is that I can take 2 and it divides evenly into 6 times 3. Now we know that's the same as 18, but because 2 divided into 6, I also know that 2 also divides into 18 because 18 is simply a multiple of something earlier that 2 divided into. Okay. Let's take a look at some other theorems and properties associated with this. So just have to bear with me for a few minutes here. There's a nice list that I want to go back and talk through. Okay, so I'm going to do this algebraically and then I'll come back and put some numbers into it. So if d divides into a and d divides into b, then d divides into the sum of a plus b. Okay, so again, let's come up with some numbers here. So let's take 2 for example. 2 divides into 4, and 2 divides into 6. So what this theorem says is that 2 would also divide into the sum of that, right? Which is saying 2 divides into 10. So, and that's true. So if I take something that two different numbers that a third number divides into, then if I sum those two numbers, I also create something that the original number divided into. Alright, let's look at another. If d divides into a and d does not divide into b, then d does not divide into the sum. So in other words, what if they're not divisible? Alright, so let's go 2 divided into 4. And 2 does not divide into 3. I think we all agree that's true. Alright, so let's consider 4 plus 3. So if I add those two numbers, right, 4 plus 3 is 7. Does 2 divide into that? Nope. So it's true. If it doesn't divide into one of them, then the sum of them is not going to also go into. If d divides into a, d divides into b, and a is greater than b, so we have an inequality at this point, then d will divide into a minus b. Alright, so let's first come up with some numbers that fit this scenario so we can kind of see this. So we'll say 2 divides into 10, and 2 divides into 4. And I know that 10 is clearly bigger than 4. Okay, so what this theorem says, or what this property says, is that 2 then would divide into the difference between those numbers. So 10 minus 4, which is 6. And that is true. That is a correct statement. Alright, let's do a couple more here. So d divides into a. D does not divide into b. And a is still greater than b. So what that says is that it doesn't divide also into the sum. Alright, so let's come up with two numbers here. All right, so 2 goes into 10. 2 does not go into 7. And clearly 10 is bigger than 7. So what that says is 2 would not go into 10 minus 7. And that means that 2 would not go into 3, which is, again, a correct statement. All right, one more. So if D does not go into A, D does go into B, and A is bigger than B, then D would not go into the difference. Okay, very similar in the wording. We're just simply saying we've got the bigger number doesn't go into the bigger number. So 2 does not go into 11. However, 2 does go into 6. And 11 is clearly bigger than 6. So what that says then is that if I take the difference, that 2 would not go into, in this case, 5. So it is a true statement. So if it doesn't go into one of the numbers, it's not going to go into the sum or difference of the two numbers. Okay, so now we're going to look at how can you tell by looking at a number if something goes into it. Okay, some of these numbers are really easy to play with, and some of them require a little bit more effort on our part, but for the most part, some of this isn't too bad. Let's start with 2, 5, and 10. Let's start with the number 2. Okay, we just have to look at the last digit, and as long as the last digit is even, we know it's divisible by 2. Okay, so for example, I'm going to make up just a 3,474. I look at the last number. Since 2 goes into 4, I know 2 goes into that big giant number. It's divisible by it. Don't know what 2 times what would do that. I mean, I could figure that out, but I just know it goes into that. Okay, for 5, the last digit is either a 0 or a 5. So 3,625. Again, look at the last digit, and I see a 5's there, so I know 5 divides into 3,625. All right, that brings us to 10. And at 10, I look at the last digit, and as long as it says 0, we're good to go. So let me do 5,625. Because the last digit is not 0, I know 10 does not go into that number. However, let me go to 5,630. Because that digit is 0, then I know 10 divides into it.